Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Karifan bin Khalid, and this will be my lab 3, which is about control volume. So, introduction. A jet of fluid may exert force on object it contacts with. So, finite control volume is used to analyze the fluid. The force is determined by using the Newton's second law or the momentum equation. The force produced is due to change in momentum or impulse that takes place as the jet strikes the surface. The study of this reaction forces is a prerequisite for understanding fluid mechanics, which can be applied to hydraulic machinery like the Pelton wheel and the impulse turbine. Firemen also use this concept to extinguish fire on tall buildings. For this experiment, we will use a flat vane and a hemispheric vane to apply this concept and study about the force produced. So, the objective for this experiment, we have two objectives. First, to experimentally determine the force required to keep a flat plate at the datum level while it is subjected to the impact of water jet. The next objective would be to compare the experimentally measured force with the analytically calculated force from the control volume form of the linear momentum equation. So the theory behind it. The law of momentum conservation states that the summation of all externally applied force on a given volume is equal to the rate of change of momentum brought in the direction of forces. In order to calculate the force caused by impact of jet onto a flat plate, principle of change in momentum is applied. So this would be the equation. Fx equal to rho q v in minus v out. So the volumetric flow rate is calculated by taking volume of fluid within a time interval. We use the formula Q equal to V over T. So the apparatus for this experiment is, we have this apparatus, we have the spring supporting level here, we have the jockey weight, we have the tally, vane jet, transparent cylinder, we have the fulcrum around here, nozzle, and this will be the from supply, and to the weight tank. So the procedures. First, we need to level the apparatus and set the lever to the balance position with the jockey weight as it's 0. Then we place a mass of 600 grams, which is a constant on the weight point, and turn on the pump. Then we open the water valve slowly and increase it to the maximum flow. Then we calculate flow rate by collection of water over a time interval. Then we repeat the experiment with different flow rate. And finally, we repeat the experiment by using a hemispheric vane. So the results and discussion. So this is the results for the flat vane. We have different volumes here. We also use different dimensions. Then we calculate for the forces and also Q. And this would be for the hemispherical vane. We also calculate forces. We also calculate Q by using different volumes and dimensions. So this is the graph, which is a graph of forces versus flow rate. So the discussion, F1 is calculated using the formula summation of Fx equal to rho q v in minus v out. We calculate F2 using the formula F equal to Wd, where W is weight and D is distance of jockey in meter. In calculating the n, use the formula V squared in equal to V squared n minus 2 gs. V out is calculated. So like the basic equation for V out is V in cos theta. For flat vane, V out equal to 0, and for hemispheric vane, V out is equal to negative Vn. If the rate of flow increase, the force resulted from the impact of the jet on both vane also increase for the F1, which is the theoretical, and F2 for the measured forces. The impact of jet forces on both subjects are clearly predicted and measured. Hemispherical vane is proved to be more efficient than flat vane due to the water exit cup that collide with water entering the cup that will reduce the flow. As a conclusion, when the flow rate increases, the force from the jet also increases. Therefore, the force is directly proportional to the flow rate. There are a few errors that occurs during the experiment, but the slight differences can be obliterated as it has only small percentage difference, which make the experiment is reliable at any costs. I think that is all from me. Thank you.